So here I am. Here we are. And I can jump back if somebody's in the waiting room. So this is what we're going to be dealing with. And the only reason I talk about when things are review is to reassure you that at some point in the past, maybe in the very distant past, but at some point in the past, you have done something like this. So all you have to do is let your brain cells remember. And so it's not totally alien. It's meant to reassure you, not like say, well, you should already know this, because I know if you don't use it, you lose it for a while. But those brain cells, they hold on to it. So anyway, here we go. And I hear ringing. Let me make sure, somebody is in the waiting room. Feel like a doctor. Who's in the waiting room? I am going to see if there's anything I can do about letting people just come in. That's what I'm doing right now. So that I don't have to worry about people being locked out. Okay, so temporarily I'm setting this to everybody can come in. We may have thousands by the end of the hour. Thousands and thousands, wow. All right, so here we go. We have these two algebraic statements, 2x minus 3y is greater than or equal to 6, and 5x plus 2y is less than 10. Okay. So, first thing, I am going to let this be green. It's always easier. I recommend working with different colors. You can steal your kids' crayons, aren't you bad? Or maybe not steal their crayons. Maybe be nicer than that. Okay, get your own colored pencils. You could do that. You don't have to, it's just more fun. Okay, and it's easier, that's all. You can do it with a pencil. Most people just do it with a pencil, and most of the time I just do it with a pencil. Okay, so the thing that you need to pay attention to is this. What are the inequality signs? If you have inequality signs that say or equal to, you're going to graph this, at least graph the line part of it, with a solid line. That's going to be a solid line, as opposed to what comes next, which is if you have a strict inequality, just greater than or just less than, you are going to use a dashed line. And that's really hard if you're working with a tablet like I am. Dazed line. No, we want dashed, but maybe dazed. Okay, that's going to be a dashed line, and you'll see what I mean. But there are some steps to follow, and if you follow those steps, this can be really easy. For instance, to graph a line, you have to graph a line and then you have to shade. So if you can remember shading from way back in beginning algebra, then you've got this thing. You've got it. If you can have a vague memory of shading something in math. Okay, that's what we're going to be doing today. Well, in my math lab and on paper, you need 2 points to graph a line, and we need to graph the line part first. So I am going to do all of this by steps, and the first step is to do this. step one. I am just going to rewrite these with equal signs. And what that's going to do for me is this. That's the straight line part. It's a line in standard form. And then now to graph any line, we need 2 points. So with standard form lines, it's just easier to make an X and a Y table. That way you don't have to bother translating, solving for Y. Okay, so what's really easy is when these coefficients go evenly into the number over here. 2 goes into 6 evenly, -3 goes into 6 evenly. Then it's really easy to set up your table like a tic-tac-toe bar, a tic-tac-toe grid, and say, okay, if X equals 0, what is Y? If Y equals 0, what is X? If X equals 0, I'll have 2 times 0 minus 3Y equals 6. So that'll be 0 because 2 times 0 is 0. 0 minus 3Y equals 6. -3Y equals 6. And divide both sides by -3. You get Y equals -2. So I know that when X is 0, Y is -2. And that's the point, 0, -2, right here, because when the X part is 0, you're on the Y axis. So I'll put a dot right here. Then I'm going to say, okay, if Y is 0, what is X? And 3 times 0 is 0. And so 2x equals 6. Divide both sides by 6, by 2 rather. By 2, and you get x equals 3. Now you're going to need that when you graph on MyMathLab, but the whole idea is making yourself a quick graph on paper before you go to MyMathLab and graph the whole thing. And we're going to find out, well, why is that preferable? And you'll see. Okay, but right now, as long as I'm into finding points, I'm going to do the same thing for the blue line here. Make an X and a Y chart, and notice that 5 goes into 10 evenly and 2 goes into 10 evenly, and that just makes this a really easy thing to do. So if X is 0, I will have 5 times 0 plus 2y equals 10. 5 times 0 is 0, so 0 plus 2y equals 10, which means 2y equals 10. And then we divide by 2 and we divide by 2. And so y equals 5. So when x is 0, y is 5. And I will put a 5 over here. And that will be the 0.05, but I'm not gonna plot it right now. Oh, I didn't plot my other green point. Careless. When x is 3, y is 0, that would be right here. Okay, I'll come back to that. Now, I'm going to find out what happens when y is 0. I will have 5x plus 2 times 0 equals 10. 2 times 0 is 0. 5x plus 0 equals 10. So 5x equals 10. Divide both sides by 5. And so x equals 2. And then I save before I lose all this. Okay, now we're ready to start graphing. So I had already started on the green line. So now that I have 2 points, let me move this out of the way. Now that we have 2 points, I'm going to get a green line here. Good enough. Okay. Now, you're still on your paper. You haven't started graphing in my math lab yet. Here's what I want to do. And now this is what makes graphing an inequality different from just graphing a line. You have to decide which side to shade on. So you're going to choose a test point. That would be step 2. Okay, so we're going to test a test point. That really doesn't look like test, does it? There. Now, a test point is any point on the grid that's not on the line. I can choose any point anywhere, as long as it's not on the line. But the easiest point, when you can get away with it, is 0, 0. So I am going to choose 0, 0 for my test point. And here's how I test it. Since 0, 0 consists of an x and a y, and both of those are zeros, I am going to take my green inequality. I go back to the inequality now. 2x minus 3y is greater than or equal to 6. I put a 0 in for x and a 0 in for y. That's the value of that point right there. I mean, you can't get easier than this. Zero minus 0, right, is 0. So we have a statement here that 0 is greater than or equal to 6, And both of those statements are false. 0 is not greater than 6. So this is going to be false. Now what that means is that any point over here is also going to give me a false. So it's not going to do me any good. But it also means, I'm going to be erasing all this when I start working on the blue. What it also means is that if everything over here is a great big F, then everything over here is a great big T. It's true. And so what I do is I am going to shade on the true side, and that's step 3. So before I shade, let's write that down. Step 3. Shade on the true side of the line. Okay, so now if you've got colored pencils or crayons, you can just color lightly. If you've only got a regular pencil, you can shade lightly with that. All right, and I am done with the green line, which means I'm going to shade. Okay. Now I'm going to do exactly the same things with the blue line. I have my points. Remember, I'm still on my paper. We haven't transferred this to my math lab yet, and I'll tell you how to do that. So first I'm going to erase all this stuff. Okay, now we go back to blue. I have 2 points I've already calculated, 0, 5, which is right here, and 2, 0, which is right here. But this is going to be a dashed line. Because it's a strict inequality. Which means I'm doing it by hand, which means it's not going to be as exact as I might like it to be. In my math lab, you can choose a dashed line. The default is a solid line, but if you look around where your line icon is, a little bit below that, you'll see that you can choose, you can click on a dashed line, and that's what you would want to do for the blue. And then you'll get a straight line. Okay, now notice that 0, 0 is free. The line does not go through 0, 0, so I can choose that point as my test point also. But first I have to return to the inequality 5x plus 2y is less than 10. Okay, and x is 0 and y is 0 when I choose the point 0, 0 right in the center. So I will have 5 times 0 plus 2 times 0. And that's strictly less than 10. So 0 is strictly less than 10, and that is true. So what that means is for the blue line, I am going to shade on the 0, 0 side. It is just so cool the way, for some reason, this blue color goes underneath the green. If you use other colors, it tends to go on top, but not the blue. The blue goes underneath. Okay, now we're done with the graphing. The whole purpose of doing all this was to discover this, where the shading overlaps. This area in here, this triangle, let me, made the whole thing disappear. Okay, this area. In fact, I'm going to be neater than that. Where the two colors are, this area in here is going to be the solution area. And if you're a business major and if you take finite math, then this area is going to be called the area of greatest probability. It has a number of different names depending on the textbook. Okay, but what that means is if you're in business, you're going to choose this area. You're going to choose a point from here. So what we did was we took our inequalities, we changed them into equalities, equations, because that's the line part. Found 2 points for the lines, graphed one line at a time so we could shade one shading at a time. And then we found where the colors or the shadings overlap, and that's the solution area. Now, you can go ahead and you can do this part in my math lab. Choose a dashed line for this line and a solid line for this line. And then, because you already know from having sketched it out on your paper that this is the solution area, you're going to drag a little paint bucket icon from where you choose the line icon. You're going to drag that in here and you're going to let it go. And this lower triangle will take on a shade, a color, showing that it's the solution of the interaction of these two inequalities. And that's the graphing and shading part of the problem. Now, if you're in business, there are a bunch of higher math proofs that prove that if you go to the vertex, V-E-R-T-E-X, you're going to see this again. In fact, you have. If you remember intermediate algebra, you have seen the word vertex as it applies to quadratic graphs. That would be the vertex. The similarity in both of those cases means that it's a turnaround point. A vertex is always a turnaround point. Vert, V-E-R-T, is a prefix, or a suffix from Latin that means to turn around. So think of all the words you know with V-E-R-T in them. Somewhere in there it's talking about turning around. Well, here, notice how if you were a little ant crawling along here, you would have to turn around at that point if you wanted to go down. So it's the turnaround point in both of these places. But in business, the vertex is where you're guaranteed to either minimize what you're trying to minimize or maximize what you're trying to maximize. So we have to find the vertex. And that is where solving systems comes into it. So we have two lines. 2x minus 3y equals 6, and 5x plus 2y equals 10. We can find the point of intersection, which is what that vertex is. It's at the intersection or the crossing point of these two lines. We have to find that point. So I'm going to use elimination to do that. Now, if I were to multiply this whole line by 5, and this whole line by -2, I didn't have to do that. In fact, an easier way, always go for the easier way. It would be easier here. I could multiply this line, if I get the marker. I could multiply this line by 2 and this line by 3. 2 times -3 is -6. 3 times 2 is +6. -6 plus +6 is 0. I could zero out my y terms and solve for x. That's what you do with elimination. You eliminate variables. So I'm going to do that. And when I multiply all the numbers in this line, you have to do all the numbers. I'll get 4x minus 6y equals 2 times 6 is 12. And 3 times 5x, that's 15x. Plus 6y. 3 times 10 is 30. If I add vertically, I'll get 19x here because 4 plus 15 is 19. But -6y plus 6y is 0. So it zeroes out, leaving me with equals 42. So moving over here where it's easier to write, I will have 19x equals 42. Now, notice, 19 doesn't go into 42, does it? We're going to have an ugly fraction. Not a nice one that like reduces to 3/2 or something like that. Okay, So that's what X is. Right here, the X coordinate of the vertex is yuck 42 over 19. Now I have to find the Y coordinate, and I'm going to save before I do that. Okay, now I need more room, and I'm going to erase the vertex, the word vertex. Okay. I could, if I wanted to suffer a lot, take 42 over 19 and put it in for X and then find out what Y is. But when I'm stuck with an ugly, ugly fraction like that, which I think I'm going to put over there in the corner. Ah! No. See what happens when I think, okay, I'm going to say divided by 19, divided by 19. So my 42 over 19 is going to be there. That will give me more room. Now, I am going to do elimination again. This time, I'm going to have to eliminate the X's because I eliminated the Y's before. I'm going to eliminate the X's and that way I can solve for Y. So I'm going to have to do what I first didn't really want to do, and that is multiply 2x minus 3y equals 6 by 5. You'll see why. And 5x plus 2y equals 10. I will multiply by -2. Now here's the reason. If I multiply 5 times 2x, I'll get 10x. If I multiply -2 times 5x, I'll get -10x. When I add those together, I will get 0, and that's what I need. These other numbers are just along for the ride. Okay, so this will give me 10x minus 15y equals 30, and -10x minus 4y equals -20. Now 10x minus 10x is 0. -15y plus -4y is -19y. And 30 minus 20 is 10. I'll divide both sides by -19, -19. The -19s cancel out, and I'm left with y equals -10 over 19. My math lab does not like you to leave the negative on the bottom. Okay, so this will be -10 over 19. And that's my vertex. Ridiculously ugly fractions. And in business, of course, you would find decimals. But my math lab wanted us to find fractions. We found fractions. And so this is like a two-step problem. You've got to find the vertex you've got to graph the inequality, which includes shading. So the most common problem that students have is they forget to shade. When you've got inequality signs like that and that in the very beginning, you have to shade. Okay, in beginning algebra, you did one at a time. In college algebra, you actually, in intermediate algebra, you did actually do this, but you didn't have to find the vertex. What makes college algebra different is you have to find the vertex so that business majors, when they go to finite math, will already know how to do this. Incidentally, it's used for other things too. Shipping, a lot of shipping, but that's business. Yeah, it's used in business. Okay. But this very method is what we're about to use here. And this may be something different unless you've had this class before, or unless you had a really advanced class. You have not used three variables, X and Y and Z. What that is latitude, longitude, altitude. If you've been in the military, you're probably familiar with that. We are actually stepping into real life here, and we're dealing with 3 dimensions. Okay, suppose you have a missile coming, an enemy missile, coming toward the United States, and you want to blast it out of the air. You're going to send 2 other missiles to destroy it, 2 interceptor missiles. That's what these are. These are the paths of the missiles. Not really, but they would be ugly with decimals and stuff. The equations would be, but you would have latitude, longitude, altitude, and these would be very, very important. You might even include time, because we wouldn't want them to miss, would we? Because they maybe the interceptors go through that point an hour later. That would be a disaster. So you want to include time too, but we're not that far along. We are going to use, in order to find the correct altitude, well, latitude, longitude, and altitude, we're going to use a matrix, okay? This is what a matrix is. And I am going to make a matrix out of this. How you make a matrix out of 3 lines in 3-dimensional space is you take the coefficients. Now don't forget there's a 1 in front of the Y and a 1 in front of the Z, and a 1 in front of the Y, that's kind of a curly 1, and a 1 in front of the Y. Even when you don't see it, there's a number there. And the minus sign also goes with the Y, so you end up getting a -1. You'll have 8, -1, 2, and 25. You'll have 2, 1, -1, and 2, and you'll have -6, 1, and 3, and -10. And this is called a matrix. And for reasons I don't know, you have this little dashed line separating what's called the coefficient matrix from this line, which makes the whole thing an augmented matrix. You don't have to know that unless you're a business major and you're doing this next semester. But I'm just telling you. okay? What we're going to do is we're going to deal with these numbers, and we're going to use what's called Gaussian elimination. There's another method too, but we are going to use only Gaussian elimination because it's easier for beginners. Okay, so these are really, this is going to feel really strange to you if you've never done this before. But Gaussian elimination requires you to take certain steps. We're going to take certain steps. And here's our goal. Here's what we're going to be working toward. We're going to use elimination to get a 0 in this position. Why? Because Gauss said so. And you will see that it actually does help you solve this matrix and find out what X, Y, and Z equal. So we're going to our first goal is to turn this position into a 0. Our second goal is to turn this position into a 0. And our third goal is to turn this position into a 0. Okay, and you'll see how that's done. This is called row 1, row 2, and row 3. You have column 1, column 2, column 3, and column 4. And for that reason, this is referred to as a 3x4 matrix. Okay, so here we go. I have to write my recipe. Some people call it a recipe. Some people call it a strategy. But what I'm doing is this. I need to add vertically just like we did before and get a 0 in that position, which means I'm going to use this and this. Now I know that 2 goes into 8. So it would be fairly easy if I could, it would be to get a -8 here or a -8. If I were to multiply that 2 by -4, then I would get 8 minus 8, which would be 0. So that's my strategy. I am going to take row 1 just as it is and add it to -4 times row 2. And the answer I get is going to substitute for row 2. This is called row operations or row ops. Okay, so here's how I do this. I'm going to come over here and do it. Row 1 is going to be 8, -1, 2, and 25. And -4 times row 2 is going to be -4 times 2 is -8. -4 times 1 is -4. -4 times -1 is +4. And -4 times 2 is -8. And then I pop up here just to make sure that I copied everything correctly, because I always worry about that. That's the most common error. Do you know that people will do everything right and then make one little error? That's what I do. So you have to watch me. I hate arithmetic. I hate working with numbers. I would much rather work with letters. That's the attraction of algebra to me. Okay, I'll add vertically now. 8 plus -8 is the same thing as 8 minus 8, and it's 0. -1 plus -4 is -5. 2 plus 4 is 6. And 25 plus -8 is the same thing as 25 minus 8, and that's going to be 17. Now this is going to be my new row 2, and here's how that works. Down here, I'm going to put row 1, row 2, and row 3. I'm going to copy the new row 2 in here. 0, -5, 6, 17. The original row 1 stays the same. And the original row 3 stays the same. Okay, boom, 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 boom. We now have ourselves a new matrix. We're going to do this fun thing again, row ops. But this time we're going to use row 1 and row 3. Well, I know that 8 and 6 will both go into 24. 8 into 24 goes 3 times, and -6 into 24 goes -4 times. So here's my strategy. I'm going to multiply row 1 by 3. That'll give me a positive 24 there. And I'm going to multiply row 3 by 4. That will give me a -24 there. Okay, and again, the other numbers just come along for the ride. So 3 times row 1. I didn't have to do it over there. Three times row 1 plus 4 times row 3 is going to give me the new row 3. Or just row 3. I just put row 3 up there, but it really was new. Okay, so 3 times row 1 is 3 times 8 is 24. 3 times -1 is -3. 3 times 2 is 6. And 3 times 25 is 75. Now 4 times row 3. 4 times negative 6 is negative 24. 4 times 1 is 4. 4 times 3 is 12. And 4 times negative 10 is negative 40. And then I add vertically. 24 plus negative 24 or 24 minus 24 is 0. Negative 3 plus 4 is positive 1. 6 plus 12 is 18. And 75 minus 40 is 35. And this is going to be my new row 3. It doesn't get more exciting than this. Row 1, row 2, row 3. We will now have a 0 and a 1 and an 18 and a 35. Now, row 2 and row 1 from up here stay the same. I'll use this. Okay. I have 1, 0 to go. And then there won't be any more row operations. I'm going to turn that 1 into a 0. I bet you can guess by now. I'm going to leave row 2. Yeah, we have to use row 2 and 3 now so that we can add 0 and 0. No matter what I multiply these guys by, any number times 0 is going to stay 0. If I were to bring row 1 into this, I would end up losing my first 0. And that would be tragic. Okay, so I'm going to leave row 2 just the way it is. And I'm going to add it to 5 times row 3. And they will add together to be the new row 3. I have to do it again. I have to have row 3 twice because I'm putting 2 zeros in there. Okay, so row 2 is going to be 8, negative 1, 2, and 25. And 5 times row 3 is going to be 0. Yes? Oops, oops, oops. What did I do? How silly. No, thank you. See, it's mind-numbing. It is so boring doing this. Did I say that? But it is. Okay, now. Okay, yeah. 5 times 18. Is that going to be 90? Yes, it is. And 5 times 35. Yuck. 15 plus 2 is 17. Is 175. So yeah, 5 times 18 was 90. Okay, okay. So, do we have any negatives? No, okay. So 0, 0, 96, And 7 plus 5 is 12, carry the 1, that's a 9, and a 1. So we now have a new row 3. Let me get rid of these calculations and pretend I always knew it in my head. No, actually, I just need more room. So row 1, row 2, row 3, I will have 0, 0, 96, and 192. And up here, row 2 stays the same, 0, negative 5, 6, 17, and 8, negative 1, 2, and 25. And this is our last matrix. Because what we're going to do now is back solve. From here, once you have your 3 zeros down here, once you have 3 zeros down there, you start doing something called back solving. And here's how you do it. You start with row 3, then you go to row 2, then you go to row 1. But first, we're going to rewrite this the way it really is now. This is 8x minus 1y plus 2z equals 25. Negative 5y plus 6z equals 17. And 96 times z equals 192. Let me save. Now this takes practice before you have it memorized. However, it doesn't take that much practice. So I think I only put 4 or 5 homework problems in your homework. So as not to strain you, but you do need to practice it. Okay, so first, 96z is going to equal 192. And I divide both sides by 96. But is it 2 times 96? Does 96 go into 192 twice? I think it does. Let me get my calculator. I'll need it now. I don't know if you can see my calculator, but trust me, I've got it. But it's virtual, so I'm waiting for it to warm up. Okay, 192, 192 divided by 96. Boom. Yes! Okay. So we now know that z equals 2. Now I go up to negative 5y plus 6z, and z is 2, equals 17. So negative 5y plus 12 equals 17. Subtract 12. Subtract 12. 12 minus 12 is 0. I'll have negative 5y equals 5, and divide by -5, and divide by -5. So y equals -1. So I've got z, I've got y, and then finally, (8x minus 1 times -1), that's what y is, plus 2 times z, and z is 2, equals 25. So this is going to be 8x plus 1 plus 4 equals 25. 8x plus 5 equals 25. Subtract 5 from both sides. So 8x equals 20. Divide both sides by 8. X equals 20 over 8, but let's see. 20 is 4 times 5. And 8 is 4 times 2. So the 4's cancel, and this reduces to 5 over 2. Ta-da! Now, when you learned how to graph, you learned that points are called ordered pairs. Like for instance, if you have an X and a Y axis, and you had, this point might be 2, 3. And it's called an ordered pair because order matters and pair means 2. But in 3-dimensional space, where you have latitude, longitude, altitude, 2 points are not going to do the trick. Instead, you have what's called an ordered triple. And you write it like this. Actually, you write it like this, because points always have parentheses around them. X is 5 over 2, comma, Y is -1, comma, Z is 2. This is your ordered triple that describes what point in 3-dimensional space this would be. And we have solved a matrix. If this is your first time to solve a matrix, you should pat yourself on the back. What you're going to do is exactly the same steps I did, over and over and over again until you can't stand it. And if you make a mistake, you will make a mistake. The mistakes are just little arithmetic errors that you've made along the way, because those little arithmetic errors are so easy to make. All you have to do is let your concentration go for 1 minute. And I'm pretty ADD. It's hard for me to concentrate on this, as you saw. That's why I don't like it. Imagine what it's like grading it. Blah! And let's go back to this. Let me make that a little smaller. Okay. I think it's really cool in my math lab, the way you can drag that little paint bucket. What they need to do is animate it more so that you can actually see the paint bucket tipping over and the paint pouring out. That would be great. Maybe sometime in the future. Let's go over what we did here. First step, change the inequality signs to equal signs so you can graph the lines. It's typically easier to work with one line first, complete with the shading on your scratch paper, and then go back and work with the other line. And then, yeah, to shade, you have to actually turn it back into the original inequalities. So you draw the line, you find a test point, you test the test point, and then you shade on the true side. On your paper, you're getting 2 points, so it'll be easy to graph those on my math lab. And then, yes, the shading you already know from your scratch paper, so you know where to drag the little bucket. You're not going to drag it there. You're not going to drag it there. You're not going to drag it there. You're going to drag it here, or wherever the overlap of the colors are on your scratch paper.
Quick question.
Yes.
Is it safe to say that we can always use 0 as our test point?
No, because occasionally you're actually going to have a line going through 0, 0.
So
and
how
then
do we determine what our test point is?
It could be any point. It could be the point -6, 5. And -6 would go in for the X, and 5 would go in for the Y.
So it's, again, it's just for the test point, it's any number that doesn't fall on the line we just made.
Right. We have some extraneous noise. Thank you. Yes, the test point has to not be on a line.
Okay, that makes sense.
Okay, good. Anybody else? If you don't have questions, you're free to go now. But if you do have questions, hang around. Nobody's asking anything.
Back to the matrix.
Okay, back to the matrix.
Figure out to get to the zeros and determine what we're going to multiply by that row. It's whatever we can figure that gets us to 0.
Right.
Okay.
And you might not choose the same numbers I chose, and that's fine.
Okay.
Those are the 2 best questions. You get the prize.
And then one last question. When we're figuring the second 0 on row 3, we will use row 2 as opposed to row 1, because if we use row 1, we'll get a number as opposed to a 0, correct?
Right, correct.
Okay.
More. Gosh, you've got me all to yourselves. Anything else like past homework? Speaking of which, I better save. Okay, and yeah, here we are, we're back. Amy. Oh, I just had nothing. My mouse was on top of you. I'm sorry. Anything else? You've only had to go to school, well, for this class, 1 day this week. That's not enough excitement for you wild party people. Well, I bet they're going to cope. Carla, anything else? Anybody, anything else?
Not that I can think of right now. Once I start working on it, I'm sure I will.
I promise you will, but you know how to contact me.
Yes, ma'am.
Dusty, how is your child?
She's doing good.
That's good.
Yeah, we had a scare, but we took her in and all her vital signs were good and there was no open wound, so they said she should recover fully.
That's good.
Yeah, thank you.
Well, everybody have a fun weekend, but do your homework.
All right, thank you, you too.
Okay, bye.
Thank you.